We're going to solve Project Euler problem number 17 in Haskell. The problem is if all the numbers from 1 to 1000 inclusive were written out in words, how many letters would be used? So in order to do that, we will have to convert each number between 1 and 1000 into a string and then count the letters. So I already wrote two string arrays. Here are all the numbers between 1 and 19. And here we have the prefixes that come with the numbers that are over 20. For example, you will notice in the word 21 there is 20, so that's right here. Also, we don't have prefixes for numbers that are first of all less or equal to 10, and we have no prefix in a number that is less than 20. So we'll write a function called num_toString, and this function will take an integer and it will return a string, and we will do a case analysis. So if we have a number n and the number is less than 20, then we can just look up the word for it in this array or in this list, so to speak. So we will get the entry that once has at position n. If our number is equal or larger than 20 but smaller than 100, then we will have to split up the number into two parts. First of all, the part that says which that basically tells us the hundredths part, and then we have the part which tells the 10th part. Sorry, that was wrong. We have to split it up into the 10th part and the ones part. So the 10th path, the thing in the first digit, is specified as follows. We just calculate n diff 10. That gives us the first digit of the number, and we look in this array what the word for it is. So we just look up tens at position n diff 10. For example, if we have a 22, then we would calculate n diff 10, which is 2, and go here to position 2, which is 20. So we have the 20 part. That's not all. We must then get the rest of the word for the number, which we can do recursively by calling num_toString, but only with the ones part of the numbers, with the remaining number. So that is n mod 10. Then we have the case that n is less than 1000. In this case, we do exactly the same thing. We need to split up split the first digit apart from the rest of the number. And in the case of hundreds, you'll notice that when I say 222, then the thing representing the first 2 in the number is 200. So it's basically just one of those numbers here. Actually, it's one of those numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the word 100. So we'll split up the first digit, which is n diff 100, and just look up the corresponding words, the corresponding word, and append the string 100. And then we have to make a case analysis, because if we only have a round hundreds number, for example 200, then there's actually nothing after the word 200. So if the last two digits are 0, so if n mod 100 equals 0, then we return an empty string, and otherwise we return an AND, because we say 100 and 22, for example, and then we just call the num2string function recursively with the remaining two digits. The remaining two digits are calculated via n mod 100. Okay, and then there's actually one more case, which is if n is equal to 1000, and in that case we will just print out 1000. You will notice that I left the space out because we are only interested in the number of non-white space characters and non-hyphen characters. So that's our function num2string. In our main function we will now do the following. We will first of all we'll generate a list from 1 to 1000 and map these numbers to their corresponding strings. Num2string. But we are not actually interested in the strings, we are interested in their length. So we will just do length afterwards. Okay, now that we have the length of the strings of all the numbers, we can sum them up and print them out. Now we can compile this. Print, not prine, thanks, and run it with time. And as you see, we get the correct answer. Thanks for watching.